In this video, I'm just going over some mixture of practice problems, but focusing mostly on graphs and piecewise and also even radical graphs and functions here. So here in number 1 through 3, we're using this piecewise function. So in looking at to see which graph here or which function represents this piecewise, here just always, if you need to, start with the interval here, right? The domain. So I notice here, starting at the x value of -3, I'm going to the left, so I'm going less than, and it's an open, I'm not including -3, so just strictly less than. So I already tell A was greater than, I can cross out, as well as B. I can also go ahead and cross out because both said greater than. So then here, with the next piece, we are starting now at -3. Notice how we have less than or equal to now because it's closed in. So we need to include it. And then stopping at 1 here, the x value of 1. Notice how it's an open, so just strictly less than, no equal to. So looking at these, so far, so good. So now let's go to the last piece. Here again, we're starting at the x value of 1, going to the right. And because it's closed in, I do need equal to. So they are both with that domain. So now notice the differences with this third piece, the absolute value. Either we have x plus 2 or x minus 2. So if you recall with absolute value, inside was your left and right. The outside was the up and down. So notice, for example, how they're both at -7. Well, this here got shifted down 7 units. So here, this is the start, right? That's our kind of like the 0, 0 here. We went 2 to the right and then 7 down. So if we're going 2 to the right, which of these represents 2 to the right? C, because remember on the inside, it's opposite. Then of course you could graph this in Desmos and check to make sure that it matches the graph. So now here in number 2, oh, actually I just realized, let me keep that. So number 2, this is just practicing the average rate of change. Remember, average rate of change is your slope. So if I'm looking at the slope over the interval, which is the x's, starting here at -2 and then going to -1. So we're looking at this portion here of the graph. So from this point to this point here. So remember, notice how this is going down. So this slope is negative. Oops, sorry, my fault. I was about to start writing the answer, but so that you guys can see, so negative. And then we're going down 3, 1, 2, 3 over 1. So down 3 over 1, so that's why the slope is -3. So here with 2b and 2c, let me just erase all this so you guys can see. So with 2b, again, we're looking at 3 to 5. So the x values are 3 to 5. So we're looking at from this part to this part of the graph. Notice the slope is going up, so we have a positive, up 1, right 1, up 1, right 1. So the slope is 1. So then 2c, starting with -7 to -5. So we're going and looking at this portion of the graph here. So we are, again, notice how, reading it left to right, so the slope is negative. Then here, I'm noticing these points here on my graph. I'm going down 2 over 1, down 2 over 1. Now, you could say from that, or you could see that if I wanted to connect from the start to finish, that this was 1, 2, 3, 4 over 2. So if I have 4 over 2, that is the same as what we got, which was -2. Then evaluating. So this was, again, going back to using the x value, because think about it, right? That is your f of x. So in this case, this is x here. My x is 4. So going back to what we have here, there are 2 ways that you can evaluate. So here I've got my 4, so x is 4. Well, is 4 less than -3? No. Is 4 between -3 and 1? No. Is 4 greater than 1? Yes. So we are using this third step here, this third piece. So here we have the absolute value of x minus 2. Well, x is 4. So 4 minus 2, then minus 7. So here I've got absolute value of 2, which is just 2. And 2 minus 7 is negative 5. So f of 4 is negative 5. Now, this means that the point x is 4 and the output y is negative 5. So if you notice here at x is 4, what point do we have? Down here at negative 5. So notice how that matches. So here in f of negative 2, well, is negative 2 less than negative 3? No. Is it between negative 3 and 1? Yes. So we're going to use the x squared here, but instead of x, we have negative 2, and negative 2 squared is 4. So 4 is that output. So what this means is, again, that the point x, negative 2, output y, 4 is on the graph. So here at negative 2, we're looking at this part of the graph, which is at 4. So now for here, we are using this piecewise to answer these two questions. So like, for example, talking about t-shirts, if you can get 51 members of the math club, how much will each shirt cost? So looking at the 51 members here, which is greater than 50, notice we're using 8 times x. So how much will each shirt cost? Well, each shirt is going to cost $8. Because how are we going to figure out how much the 51 shirts are going to cost? Well, we're going to multiply that 51 by 8. That's 8x, and x is 51. So that's how you end up with the total amount of $408. So if you only have 5 members, then how much will each t-shirt cost? Well, 5 is between 0 and 10, so that means the cost is $12 each. So what is the cost for the 5? Multiply that by the $12. And that's how you end up with spending $60 total for those 5 shirts. So number 5 is the same now, just in the graph form. So here, if I want to know if I'm buying 4 to 6 cookies, so again, 4 to 6. So here is 4 and 6. What is the cost of each cookie? Well, if you think about it, guys, it's asking for the slope, the rate of change. So notice how we're going 1, 2, 3, 4 over 2. So if this is 4 over 2, then that means we have our slope of 2, which means what's the cost of each cookie? $2. So then here, if you have 2 to 3, so 2 to 3 cookies, well, 2 is here and 3 is here. So 2 to 3. So we're looking at this portion of that graph. What is the cost? Well, again, we're going 1, 2, 3 over 1. So the cost is $3 because you have a slope of 3. So then here, if you're buying 10 to 12 cookies, so 10, 12 cookies. So 10 is here and 12 is here. Looking at that portion of the graph, what is the cost of each cookie? Well, here you're going up 1, right 1, up 1, right 1, or up 2 over 2, which is still showing 1 or $1. So now in number 6, here we're getting into, guys, practicing using Desmos. So if you want to know the answer to these questions with the constraints, then we'll be practicing using Desmos to figure out the maximum and minimum values. So here we're going to let X represent hamburgers and then Y represent the chicken. So here, if hamburgers cost $2 per pound, so I need 2x, right? Because X is hamburgers. And then chicken is $3. So chicken, that's your Y. And then you can spend no more than $30. So if it's no more than, then it has to be less than or equal to 30 because you can't go over that. So I can already tell that A is not my answer. B is good, C is good, But D, notice how those coefficients here, the 3 and 2, got switched. So D. So here now, let's continue on. It says that you expect to purchase at least 3 pounds of hamburgers. So again, hamburgers was the X. So X is saying we need at least 3. So X is greater than or equal to 3. That's why it's C. Because then that means if we don't necessarily know the amount of chicken, then we know that we need to at least get a positive amount, right? Because can you get a negative amount of chicken? No. So that's why here it's understood that we need greater than or equal to 0, because you could still get 0 hamburger or 0 chicken. So now, what is the most? So this is like maximizing. This means we need to get the solution, but we need to get the vertices of the solution region. So you need to practice graphing these 3. So now we know what our answer is. These are the constraints in Desmos. So notice by the shading, we are covering and looking at this triangle here. So we're looking at the vertices of our shaded region. Oops, sorry about that, which are 3, 0, 15, 0, and 3, 8. So here we're looking at 3, 0, 15, 0, and 3, 8. Now, if I want to know the most, I can already tell that 3, 0 is not going to give me the most, because that's only 3 total. Because this is X and this is my Y, right? Remember, X is hamburgers and Y is chicken. Well, that's just saying I'm buying 3 hamburgers and no chicken. So that's only 3 of each of these, or 3 of those 2 together. But we want to know the most. So here, 15 hamburgers, 0 chicken, so 15. Here we have 3 plus 8, which is 11, because 3 hamburgers and 8 chicken. So notice that with these constraints, that the most you can buy is 15 items with these constraints, 15 hamburgers and no chicken. So now in number 7, it's giving you the constraints. So again, you need to practice graphing these in Desmos. Then it gives you the profit. Now, mind you, this is $50 and $80. So we are again looking for the maximum profit. So after graphing those constraints, you need to see what are the vertices, the corners of that solution region. And so now after graphing, you'll see that, right? Everything needs to be positive, but we also had the other constraints of being less than. So we're looking at this region here where the vertices are the 6, 4, 8, 0, 0, 6, and 0, 0. But really, we're not going to include 0, 0 because that's definitely not going to give us a maximum profit because that represents nothing. So here I'll go ahead and record. So we have our vertices of our solution region. So 0, 6, 6, 4, and 8, 0. Now, if we're looking for the maximum profit, now we're going to use, again, right, this is my X, this is my Y. 50 times X plus 80 times Y. So like here, this is, if you think about it, 50 times, well, what's the X? 0, which is just nothing, right? Goes away. And plus 80 times Y, which is 6. So this represents $480. So now let's go to 6 and 4. So this is 50 times X, which is 6, plus 80 times Y, which is 4. This now gives you $620. So I can already tell that 480 is out, right? So 620. So now let's go to the last here. 50 times X, which is 8, plus 80 times Y, which is just 0, which goes away. So this is $400. So that's why the maximum profit is $620. So in number 8, same thing. You're given the, oops, sorry about that. You are given the constraints to graph. Now keep in mind, everything's a greater than, so this one's going to be a little different. And it's asking for the minimum value. Now again, This is the function that we are going to use in terms of the expenses. So $1.89 times X and $2.89 times Y. And so now after graphing these constraints, notice the solution region, because everything was greater than, is up above out in the open in this greater than region. So like here, the corners are, the solution region of the corners are here at 8.0, 4.2, and 10.0. This is the region that we are looking at, and then above. So these are the three vertices we're going to look at. So 0, 10, we had 4, 2, and 8, 0. Now again, same thing, right? We're going to use that function to figure out which is the minimum value. So again, $1.89 times X, which is 0. So again, that goes away. Plus $2.89 times Y, which is 10. So this gives you $28.90. So now here we have 189 times X, which is 4, plus 289 times Y, which is 2. So when you calculate this, you end up with $13.34. Well, we need the minimum, so I'm going to cancel that out. And here, 80. So here I've got 189 times X, which is 8, plus 289 times Y, which is 0, which cancels out. So here, when you multiply, you end up with $15.12. So notice how the answer was B. So now 9 and 10 is going back to our graphs, just reviewing, getting that practice in. Here we have our log, and here we have our exponential. So again, we're looking for the false statement. So remember, log, the range is what is all reals, because constantly going up and down, because we have a vertical asymptote. Remember, this looks like it's flattening, but it's still going up, 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 up. And the vertical asymptote is here at X is equal to -3. So actually, I can already tell that A is true, but B is the answer. B is false, because it's not the domain that's all reals, it's the range. So everything else was true. As X is approaching infinity, as we're going to the right, the graph is going up. And as X is approaching -3, the asymptote, the graph is going down. Now, number 10, same thing. We're looking to see which statement is false about the exponential. So now again, the domain is all reals, right? Because the graph is constantly going left and constantly going right. And we now have the horizontal asymptote, which is here at Y is equal to -2. So here, A is true. Now, B, as X approaches infinity, as we're going to the right, our graph is going up to infinity. So that is true. Here the range, the Y values are starting at -2 and going up to infinity. So let's see if D is the false statement. As X approaches negative infinity, as we're going to the left, is the graph going all the way down to negative infinity? No. What is the end approaching? -2, the asymptote. So that's why the answer here is D. And number 11. So here, just that reminder, because it's been a while, with the radical equation. So we can solve this, right, by calculation or algebra. The radical is by itself, so I'm going to go ahead and square both sides, so the radical cancels. Now here, notice you do need to do box method. So that's 2x minus 10 times itself, 2x minus 10, or FOIL. So here you've got x squared minus 4x minus 5 is now going to be equal to 4x squared minus 40x plus 100. So that's what you should get here after using box method. Now notice you're solving a quadratic, and quadratics have to equal 0. Now you could subtract 4x from both sides of the equation. However, then you would get a negative. So I'm going to move this over so that it stays positive. That means we need to add 4x to both sides and add 5 as well to both sides. So here we've got 0 is equal to 3x squared minus 36x plus 105. Now notice we actually remember you don't go straight to bottoms up because there is a GCF. We have a GCF of 3. So after taking out 3, dividing everything by 3, 3 divided by 3 is 1, so x squared. Negative 36 divided by 3, negative 12x. Then 105, but divided by 3 is now 35. Now we can factor. So here, what two numbers multiply to get 35 and add to get negative 12? Negative 7 and negative 5, which means, remember when solving that GCF cancels out because 3 never equals 0, but x is equal to 7 and 5. So I'm going to cross out D because it includes the 3. But then remember to check for extraneous. Go back to the original equation. So 2x minus 10, because remember, right, it can't equal a negative. So 2 times 7 minus 10. Well, that gives you 4, so 7 is good. And 2 times 5 minus 10. Well, that's going to give you 0, which technically still works because it's not a negative value, because the square root of 0 is still 0. So we are saying that both are solutions. Now, you can also graph this in Desmos to check your work, because we're saying that this has two solutions crossing at these two values. So if you were to graph this in Desmos, remember, right, you have the left side on one line, the right side on the other line. Notice here how they are crossing at 2 points. Here at x is equal to 5 and x is equal to 7. So it does match our solution here. So now here in number 12, we're given this situation that models, we're talking about the shoulder height of a male elephant is modeled by this equation here. So we have the height of the elephant, or the shoulder height, here, and then T is representing the age in years. So what does the 75.8 represent? Well, notice how the 75.8 is the value here that's being added, as if this is like the y-intercept. Because remember, when multiplying, right, even take out the cubed root. If this was just 62.5x plus 75.8, well, we would say that 62.5 is the slope, the average rate of change. So notice how average, anytime you see average, you're talking about the slope, the rate of change. But notice how 75.8 is not that. That's the y-intercept where it's crossing the y. So a C and D are not going to be an answer. Now here, we just have to now remember that the 75.8 represents what? Well, if it's at the y, right, visually at the y, and you could graph this in Desmos as well. If you were to graph this in Desmos, you would see that this graph is starting up way up here at 75.8. But this is at 0, right? The point is 0, 75.8. So then what are we saying? Is this the expected shoulder height of a newborn or the maximum shoulder height of a male elephant? Well, if the x is 0, meaning that's the start, then that is the newborn. That is the start. So that's why the answer is A. And then again, you can always graph this in Desmos to actually see the graph and understand what this represents. So now in number 13, here's actually where you're given the equation and the graph is shown to you. Now, this is S, which is the speed of the tidal wave, and here. And this is equal to, notice our input, that's your T here, representing time. So if you recall, T, time, That is your input, as if like this is your X. That is your domain. So this is my time. So what is the time in this case? Well, here, can our graph go into the negative? No. So you have to keep that in mind that yes, we could go on and on and on, but truly, if we're talking about time, we have to make sure that the domain represents the situation. So we are going from 0, right? But we're stopping at 4. So here, and again, my x's, according to here, my input, that is my time. So that's why the answer here is D. So again, which is invalid? What makes this not true? Well, like what we just said, can you travel a negative speed? No. So this is the portion that is invalid, starting at 4 and going on to infinity. That's why the answer here is D. And so now the last question here, number 14. We're talking about these two functions. However, notice how one is equation and one is a table. And we're talking about the domain and the end behavior. So we need to actually visually see these and use Desmos. So again, graphing the first in Desmos. So that square root, right? So now we can visually see this graph. How it has, again, the starting point, which is here. Let me zoom out right quick, or zoom in right quick. So we have that starting point, which is here, and then going on, right? Because it's a square root, it's a radical going on in one direction. But what you have to remember is how can we also see this visually and graph the table in Desmos? So if you don't remember, graph a table in Desmos. When you start that line, you're now going to click the plus sign because we're going to add a table. So we're going to go ahead now and put that table in. So again, notice how the X is here. And then remember, this is your Y. So that's your G of X because this is your other function. So here I've got, so now we can just start typing in those values. So creating the table. I just realized, hold on 1 second. Sorry about that. There we go. Okay. So now that we've graphed the table, you can actually also do something because right now it just looks like we have a bunch of points, right? So if you have difficulty seeing what this graph would look like, what you could also do is here is you can actually connect these points. So if you wanted to, so what you do is, so again, right? Put a table, you press that plus sign to put the table. So now if you want to make a line, what you do is you click on here, click on actually, yeah, sorry about that. I just now remembered. Click on the setting because we're going to edit it. We're going to edit this to make a line. So again, we're going to edit, and this is what we want to edit, and we want to create a line. So now notice we have created a graph here. Now you also have to keep in mind though that this table has a starting and ending point. Technically, this is going to go on and on and on. So the table really doesn't have a starting and stopping point. It's going to go on and on and on. So you have to remember that this graph is going on and on in both directions, as if this is the cubed root. So this is our cubed root function. And this is our radical function. So here is the domain all reals for both functions. Well, remember the radical function. Is the radical going on and on in both directions? No, because remember the radical, let me take that off real quickly so you guys can see, has the starting point for the domain and only going to the right. So is number 1 true? No. because the domain is not all reals for f of x, only g of x, because that will be constantly going left and right. So I can cross out A and B. So now really, if you notice, use test-taking strategies. 2 is a correct statement, but we need to decide if it's 3 or 4. So now we're looking at the end behavior. So here, as x approaches infinity for f of x, is f of x approaching infinity? So let's see. As x's are approaching infinity, yes, the graph is going on to infinity, up to infinity. So that part is good. Then here, as x's are approaching for the other function, as x approaches negative infinity, is the end going down? And as we're going to the right, is the end going up? So let's see. So again, remember, the table still technically goes on and on. There's just only so many values that you can put in. So here, our graph is going up as we're going to the right, and our graph is going down as we're going to the left. So 3 is also true. So let's check to make sure that 4 is false. Well, this says as x approaches negative infinity, as we're going to the left, that f of x is approaching negative infinity. But as we're going to the left for that f of x, right, that first graph here, as we're going to the left, if you recall, we're going to the left. Are we going to negative infinity? No. Boom. We're stopping at what y value? 4. So that's why that statement here is false. We're not approaching -4, or negative infinity. We're stopping at 4.